Hello my dear students, welcome you for the physics class. So today we are going to start a new chapter, that is electricity. It's okay. So in this chapter, the things that we are going to study, I think all of you have some idea about what do you mean by electricity, what is current and all these things. You have studied a little bit of positive charge and negative charge. So let's check what are the things we are going to study in this particular chapter. So first of all, the concept that we are going to study in this chapter, I will note it down. The concepts, or I can say the topics that we have to study in this particular chapter. Number 1, we will study about electric current. Here in this topic we are going to study what is electric current, what is the unit of electric current, how to measure the current, what is the device that is used to measure the current, what is the direction of current. All these things we are going to study under here. Number 2 will be the potential difference. This is a new topic for you. So when I will teach you, then I will discuss the topic. It's okay. Then the third one we will discuss regarding Ohm's law. We will discuss this with the help of an activity. But since we are doing the classes online, I cannot show you the activity, but I will show you virtually with the help of an experiment. So after Ohm's law, we will get another term, that is resistance. And in resistance, we will get what are the factors that affect resistance. Factors that affect resistances. It's okay. Next, we are going to study number 5. Number 5, it will be combination of resistance or resistors. So, combination of resistors. First of all, we will discuss the meaning of resistance. Then, what are the factors that is affecting resistance. Next, we will discuss how the resistors can be connected in a circuit. Next, number 6, we are going to study here heating effects of electric current. Heating effect of electric current. So let me tell you one example here. Suppose when we want to iron your dress while coming for the school or while going outside, we used to heat up. When we allow the current to pass through the electric iron, it gets heated up. Why? What is the reason behind it? Similarly, if we switch on the bulb filament glows as well as it gets heated up. That is the heating effect. Means whenever current passes, there will be generation of heat or heat will be produced. So that we will study here in this particular topic. Number 7, we'll study here Joule's law of heating. Okay, this is actually the same concept. For heating effect, there is a law. That law is known as Joule's law. So that one we will discuss here. We will derive also the Joule's law of heating. Then number 8, we will discuss electric power. Okay. Then number 9, if I say it is electric energy, I can say electrical energy. We'll discuss these two terms. Means what is the meaning of electric power, what is the meaning of electrical energy, these terms. And lastly, here we are going to discuss the relationship. The relation between I will write V means potential difference, I means current, P means electric power, and R means resistance. So these are the concepts that we have to study in this particular chapter. Okay, so based on this, so we have some learning outcomes or the objectives of the chapter. So the objectives of the chapters are, if I say one by one, the objectives we can say, or we can call it to be learning outcome. After going through the chapter, if I finish the chapter, after finishing the chapter, the things that we should learn from this particular chapter are: number one, we should be able to define electric current. What we should do, we should be able to define electric current. We should be able to define again electric potential. Then we should be able to define the meaning or understand the meaning of resistance. We'll find another term there, resistivity. We will be able to define this resistivity as well as the power of the circuit. So first learning outcome, or the first thing that we will learn from the chapter, is this one. No doubt we will study this at the beginning, this one at the second topic, this will come in the fourth topic, this will come fifth topic, this will come at last, but these definitions will come to know after going through the chapter. Next, we'll come to know prove Ohm's law. What we will do, we can prove Ohm's law and verify it experimentally as well as and graphically. Understood? Graphically also we can prove it. Means we can draw a graph and we can prove that the Ohm's law. Now, number 3, what we will know? We'll come to understand the series and parallel combination. So now here I said that we will discuss series and parallel combination of resistors. Now resistor means the meaning will come, and if I talk about connection of a bulb also has a little resistance. If I talk about the fan, that is also has a resistance. Any electrical device, whatever it may be, it will have a resistance. So here when we understand the series and parallel combination, that means we are connecting the what? Electrical devices. It can be two bulbs also, it can be two fan also. Yes or no? If we connect them to series or we can connect them parallel, when we will discuss, we'll come to know how they will be connected. And also, I will rub the first one, and the importance of connecting the devices in parallel. We'll come to know that if I connect the devices in parallel, then it will be better compared to if I connect in series. So this we also will come to know after going through the chapter. Then another thing we will come to know, number 4, if I say, we will know what type of material is chosen to make heating devices. Okay, let me give you an example here. Suppose I have used a bulb. Okay, the bulb, the filament, through the filament, the current will pass. As a result, what will happen? It will glow. The same type of material, if I use in an electric iron, will it work? So there must be a difference between the two materials. What material we will use and why we are choosing that particular material, also we will come to know from this particular topic or particular chapter. Another important thing from this particular chapter will come to know, you will be able to measure the electricity bill. Means how much the energy is consumed in your home per month or per day. You will be able to know, and based on that you can calculate what should be the amount of bill it will come to your every month to your home, depending upon the consumption. And lastly, but not the least, after going through, we'll learn so many formulas will be there. Then we will be able to apply the formulas to solve numericals. Okay, so these are the 6 learning outcomes of our chapter. I hope you have understood. So now we will start the chapter with the first topic, that is electric charges. Okay, can I start the now? I will start the chapter, that is electricity. The topic that I will begin today is electric charges. It's okay? Before I start, let's do an activity so that you can understand the topic clearly. Activity for this. So for this I have taken a scale and some bits of paper. Now if we rub the scale on our head, then we'll place the scale near the beads of paper. We observe that the beads of paper are attracted by the scale. This is because the scale has been charged negatively. Okay, the charged means everybody in the universe, everything have positive and negative charge. So one charge, negative charge has been transferred from the hair to the scale. As a result, so it is attracting the positive charge which are on the small papers. Okay, through this activity what you have learned, what you have seen? We have seen that the beads of papers are attracted by the what? The scale. Similarly, if I have a balloon and with the balloon I am rubbing on my hairs, and then what I am doing, I am rubbing another balloon again on my hair, and if I am bringing the two balloons together, it will not be attracted or it will not come closer, it will go away. If you have the balloon at home, try it at home. Okay. Now what we have learned there, actually what happens, suppose this is a balloon, if I say, not balloon, we have discussed regarding the scale or not. So suppose this is a scale. So what happens, every material has some charges. It has both positive and negative charge. So this, when we rub it, the negative, what will happen? The negative charges will be developed there. So it becomes what? Negatively charged. So when it becomes negatively charged, or if I have a balloon instead of the scale, if I have a balloon also, if I have a balloon like this, and if I rub it on my hair, the balloon becomes what? Negatively charged. And if I have some beads of paper which are, positively charged, then if I bring it nearer, what will happen? It will be pulled. Yes, that is what every object or everything in the universe will have, are composed of positive and negative charges. Now, what is the meaning of charge? I am saying positive charge, negative charge. You also know positive charge, negative charge. But what is the meaning of electric charge? What is the meaning of electric charge according to you? Meaning of electric charge is, it is the property of a matter. Suppose I talk about this chalk, it is a matter or not? If I talk about this pen, then this is also a matter. Or any substance, if I say it is the property of this particular substance to which causes it to experience a force, which causes it to experience a force when we place this in another or near another material or substance. Understood? So it is the property of a substance. It is the property of this particular substance. If I place this near another substance, then what will happen? It will experience certain amount of force. That property is known as electric charge. It's a physical property. Okay. So if I say charges are of two types. One is a positive charge, another is a negative charge. This is a body. Suppose I say that it has a positive charge. I'm drawing how many? I have drawn 5 positive charges. I say that there are 5 negative charges. It's okay. These are 5 negative charges. So what is the total charge of the body then? The total charge will be 0 or not. Total charge, if I write total charge, it will become 0. It's okay. But now can I say that the body doesn't contain any charge or do not have any charge? No, I cannot say. Understood? The body have charge, but thing is that one charge is cancelling the effect of the other charge. As a result, it looks like it is a neutral body or it is an uncharged body. Understood? So if it is an uncharged body, I said 5 protons are there and 5 electrons are there. What type of charge I have drawn? Positive and negative. So positive charges are what? Positive charge, if I say, positive charges are your protons. And if I say negative charge, then negative charge are the what? Electrons. Okay, in my diagram, how many positive charges are there? 5. How many negative charges are there? 5. So let me write 5 p proton. Understood? Then 5 electron. It's okay now? Now what I have done? I have removed one negative charge. Means what is the charge now? This has become 4. Electrons are 4, protons are 5. What is the total charge then? So if I say what is the total charge? Total charge if I write will be equal to, how many protons are there? 5. How many electrons are there? 4. So what is the charge? 1 or not? Yes? So am I writing plus or minus in front of 1? Plus. So the body behaves like a now positively charged body. Means if the body has excess number of protons compared to the electrons, then I will call the body to be positively charged. Okay, clear? Now if I say that the negative charge is 5 only, make it 5. But what I have done, positive charge I have removed it and I have made it 4. Then what will be the total charge now in this case? I can write this to be 4. Yes? Proton is positive, so I am writing plus 4. Then electron is negative, minus 5. So it will become what? Minus of 1. It came with what? Negative sign or not? So that means it is a negatively charged body. So positive charged body means the body have excess number of protons. Negative charged body means it has excess number of electrons. If I am comparing it with the other type of charge. Okay. If I say it is a neutral body, that means what? It has equal number of positive and negative charge. Okay, I think it is clear to you what is a positive charge, what is a negative charge. Now, as we come to know a positive charge and negative charge, we say electron is a positive charge. So now, what is the SI unit of charge? SI unit of charge is coulomb. We represent it by capital C. What is the representation? Representation is capital C. But coulomb is a very big unit. You will come to know in class 12, or if I get time and if you want, I will teach you why coulomb is a bigger unit. Coulomb is a very large unit. So basically in nature, if I'm not getting 1 coulomb of charge, I will get less. So basically while solving, while doing anything, we use another smaller units. Means I will write smaller units. Number 1 is 1 microcoulomb. When I write micro, I used to write the symbol like this, 1. Micro, from below you move it up like this. Then from there pull it down, it becomes like this. So this is micro, then coulomb. So it will become 10 to the power minus 6 coulomb. This conversion. If in numericals you are getting micro, you have to convert to coulomb, remember. Another one we will use here, 1 millicoulomb. 1 millicoulomb means 1 MC. MC means 10 to the power minus 3. So this is the 2 smaller units of what? Electric charge. Now if I say that in nature, everything, the smallest units are, smallest substance or smallest particles are what? Protons and neutrons or not? Till now, you will say that till class 10, you are saying that protons and neutrons or electrons are the smallest particles in the universe. But when you will go to higher studies, you will come to know heptons, leptons, so many things are there. Muons are there. Okay. Then what are there? Pi mesons are there. So many other particles are also discovered till now. But basically, if we talk about electric charge, positive and negative charge, the charge of proton, charge of proton and the charge of electron are equal. I have given the symbol equal here. It is equal. But remember one thing. If I say proton, then it will be positive. I have to write in front of it. And if I say electron, then I have to write a minus sign. And both the values are 1.6 into 10 to the power minus 19 coulomb. Think, minus 19 coulomb. So coulomb means what? It is a bigger unit, but basically we will be using what? Microcoulomb, nanocoulomb, millicoulomb, all these coulombs are used. Nano means, nano you know, 10 to the power minus 9. So this is the charge of a proton or the charge of an electron. And another thing I would like to say you here, mass of electron, if I say, are the masses same for electron and proton? No. Mass of electron is less compared to mass of proton. Means protons are heavier than the what? Electrons. So proton mass is, electron mass is 9.1 into 10 to the power minus 31 kg. What is the kg? Minus 31. Think how much small it will be. If I write mass of proton, the mass of proton is 1.66. 67 I can write into 10 to the power minus 27 kg. So it is minus 27. Minus 20. If I write minus 5, minus 10, which one is bigger? Minus 5 is bigger compared to minus 10. Yes or no? In powers also the same thing. So this is a bigger value compared to the mass of an electron. So we came to know that what is the meaning of electric charge, what are the types of electric charge, what are the charge values, yes or no? So these things we came to know. Now let's discuss about the properties of electric charge. I'm not going to study anything else today except the electric charge. No doubt, electric charge is not directly given in your book. Then too, we have to study because if you want to know what is current, I must know what is electric charge. So now we will be discussing the properties of electric charge. Number 1, additive in nature. Additive in nature. Additive means what? Addition. Just now we have done. A body I have taken, 5 protons I have taken, 5 electrons I have taken. What is the total charge? I have additive. Yes or no? So additive in nature means charges are addition. If you want to find out the total charge of a body, we have to add the entire charge of the body. It can be positive. Suppose I say this is a body. It has plus Q1, this is minus Q2, this is plus Q3, this is plus Q4. Then if I ask you what is the total charge of the body, you have to write Q is equals to Q1. Q2 is minus, so I will write Q2 minus. Then plus Q3, then plus Q4. So this is the total charge of the body. If the values are given, put the values, you will get the answer. It's okay. Number 2, conserved. Conserve means what? You have studied conservation of energy in class 9. Conservation of momentum also you have studied. Conservation of charge also. We can neither destroy the charge, we can neither create the charge. When we rubbed it, when we have rubbed the balloon, the negative charge, and we are getting the negative charge, extra charge from the hairs. Understood? Means that it cannot happen that the charges will be destroyed. It will be transferred from one substance to another, but it cannot be destroyed. So charges are conserved in nature. It's okay. Number 3, if I say, all of you know this, you have studied like charges. What happened to like charges? Like charges repel. Yes. And unlike charges, what will happen unlike charges? Unlike charges will attract each other. So unlike charges attract each other. So this is known to you from the lower classes. You have studied in magnetism also. North pole, repulsion, but not in south, attraction. So opposite poles attract, same poles repel. So same meaning will come. If it is same charge, positive, repulsion will be there. If it is positive, negative, attraction will be there. Okay. And the last one, which is the most important one, is this charges are quantized. Quantized. Now the meaning is, what is the meaning of quantized? What is the meaning of quantized? Okay, let's take a body. If I say it has 11 positive charge, I'm writing 11 positive charge. I'm not writing proton and electron, 11 positive charge. Then I wrote that suppose it is 8 negative charge. Is it okay? How many positive charges are there? 8 to 11 positive charges is there. How many negative charges? 8 negative charges is there. Now if I ask you what is the total charge or what is the total number of charges present, it will be 11 minus 8. How much I will get? 3. It's okay. 3 is not the charge. If I have 11 positive charge, means one charge, what is the total positive charge and what is the total positive charge? Or instead of saying positive, negative, let me give you a simple example. Suppose I say this is a body and it has 3 electrons. How many electrons are there? 3 electrons are there. So it's a what type of body? It's a negatively charged body. If I ask you what is the total charge of the body, what you will do? If I ask you what is the total charge of the body, I said 3 electrons are there. So what is the total charge of the body? If I ask you, how will you write? Total charge. How will you write? How many charges is there? 3 charges. What type of charge is there? Electron. 3 into, will I write? Charge of 1 electron. Then I will get the total charge of the body. If I have written only 1 electron is there, then what is the total charge? I cannot write 1 is the charge. I have to write that 1.6 into 10 to the power minus 19 is the charge of the body. Similarly, if I have said that it is the 3 charges are there, then what is the total charge? 3 into charge of an electron. If instead of 3 I have written, I said that 10 to the power 4 electrons are there, then it will be 10 to the power 4 into charge of 1 electron will come. Means in order to calculate the total charge of a body, what we have to do? We have to multiply by the number of charges present by what? The charge of an electron. If it is a positive charge, suppose it is a proton also. Suppose it is a proton also. If I write 10 to the power 4 into charge of an electron, will it be correct? Yes, it will be correct because charge of proton and charge of electron are same. But thing is that if it is a proton, I have to write that this is a positively charged body. But if it is an electron, then I have to write it as a negatively charged body. It's okay, clear? So, how can I write now? Quantized rule means the total charge of a body will be equal to number of electrons or protons present. Can I write n numbers are there multiplied by the charge of electrons? I am writing n into e. So in sentence if I say n will be what? 1, 2, 3, 4, 5. Any number or not? Can it be half? Suppose this is an electron and I will divide it into 2 parts and I say this is half yours and this is half mine. Can it happen? No. So it will be always as a 1 value. Or if I want to give you, I have to give entire 1 to you or I will not give anything to you. Understood? So I cannot give half or 1/4 or 1/3. So n will be always a number. So I can write quantization means it is the total charge of a body is integral. These are integers or not? So integral multiple of what? Charge of an electron. Okay. If I ask you what is the number of electrons present in 1 coulomb of charge. Suppose I say total charge is 1 coulomb. It's okay, 1 coulomb. So if I ask you what is that? Suppose instead of 1 coulomb I have written 4 coulomb of charge. This is a body and I said it has 4 coulomb of charge. What is the total number of electrons present? Then what do you have to do? Q is equals to Na. So Ne, this is Q. So I can write it as N will be equals to Q by E. So what is Q here? 4. What is N? 1.6 into 10 to the power minus 19. Solve this, you will get the value of N. Now if this number comes as a fraction, then that charge is not possible. It cannot happen. I already said that I cannot divide an electron or a proton into half and give it to someone else. Another thing is that charges are conserved. Okay, so these things we have studied today. So what are the things we have studied? We have studied nothing so much. We have studied only electric charge, its meaning, its SI unit, then what are the properties of charges for today's class. That's all for today's class. Thank you. I will meet you again in the next class. Thank you.